Good day, guys. I hope you're all doing so well. On today's episode, we are still continuing with factorization, and this question I took it from November Paper 1 Mathematics 2017 grade 10 question paper, guys. So it's factorized. I'm gonna do factorization of 2016 and 2015, then I'll be done with factorization in preparation for our final examinations. Without any further ado, let us just start. Now we've got t squared bracket r minus s close bracket minus r plus s. Now this is factor by grouping. This factor, or this type of factorization, guys, it involves making sure that you've got two brackets that are the same in terms of the expression, in terms of the way you write the expression. In this case, I've got one bracket of r minus s, meaning let us find another bracket that will be similar to, or that will be the same as this one of r minus s. Or we can literally find two brackets that are the same. So now I can see that there's r plus s here. It is similar to r minus s. Therefore, let me just try to create another bracket that involves this one, this expression that is outside this bracket, this one, r plus s. Because you know how this type of factorization works. Now, in this case, let us try to find another bracket that is similar to r minus s. Already, r plus s, it's similar. Now, I've got t squared. I'm going to leave this one for now. R minus s. Now, here's the thing. What's about we have got -1 more, and I've got +1 more. Now, what is common between -1r plus 1s? What's common? 1. Therefore, I can take this -1 outside the bracket. This -1, this one, -1. Already. Then I open the bracket. You know, our culture says if for me to find the expression that will sit here, I need to divide the first term with my common factor. -1r divided by -1 is r, because I know -1 divided by -1 is 1. Therefore, I bring down this r here. 1s divided by -1. +1 divided by -1 is -1, and I'm left with s minus s here. It's very simple like that. I hope we are clear on that. Now, my brackets are the same. Therefore, they are common, and bring one down. Bring only one bracket down. R minus s. Then what's left outside, put it inside another bracket also. What's left outside is t squared minus 1. T squared minus 1. You're not done. Then you're okay with this one. Now, there's something that is appearing, or that is prevailing right now. It is this thing, t squared minus 1. Now, whenever you see a squared and a minus in the middle, this is called difference of two squares. We call this difference of two squares. How do you treat it? It's so important to familiarize yourself with difference of two squares and how to solve expressions that involves it. You'll know it by having a squared and a minus in the middle. As long as you've got two terms, this is the first term and the second term. If you have got two terms and a minus in the middle and a squared, then that expression is the difference of two squares. Then how do you simplify it? You need to simplify further. It's a must to simplify it further. Now we've got r minus s. Then the difference of two squares, you must know it by opening two brackets. First thing first, open two brackets. What are factors of t squared? What's like t and t? Now, which two numbers can I multiply to give me 1? Which two numbers can I multiply to give me 1? 1 times 1 is 1. Therefore, it's 1 and 1. And minus, there's going to be difference. There's going to be opposite signs here and here. You can put positive here, negative here, or vice versa. It will depend on which one you start with. It's your choice, guys. I hope we are clear on this one. Let us go to 1.2.2. 1.2.2. Guys, it says that x cubed plus 1 divided by x squared minus x plus 1. Now this one is very complex, but it's simple, ne? Because in your textbook they break it as our numerator. It's a question on its own in our textbooks, and our denominator is a question on its own in our textbooks. But in the examination they combine them. Usually they combine them, but let us simplify it as if you are using the textbook literally, ne? Now let us look at our numerator. Our numerator has got x cubed plus 1 again. X cubed plus 1 again. The simplest method for this one, we're going to have two brackets basically, ne? The first bracket, it involves these two terms. Again, another cubed already. If you have cubed in this case, you might introduce the cube root of x cubed, the cube root of x cubed, and the cube root of 1. What is the cube root of x cubed? X, because this 3 will cancel this 3, then be left with x here. I'm gonna write it here, x. What is the cube root of 1? Is 1. Therefore, it will be 1 here. I hope we are clear on that. Then this sign remains the same, positive here. Are we clear? You open another bracket again. Right, guys, you always do that. In most cases, you always do. For if you've got x cubed here plus 1, you start by finding the cube root of each term. The cube root of x cubed is always x. The cube root of 1 is 1 if you put it on calculator. Then the second bracket, you will say that which term can I multiply with x to give me x cubed? I get an x to power 1 more. So which another x? I get one x more happy. Now for me to reach to x cubed, I need to have squared. When you multiply same basis, you add what? Exponent. 2 plus 1 get 3. Which means on this place, that's where it sits a factor. That's when you on this place, it is where it sits. This place it is reserved for an exponent couple, a term of which that will multiply with this one to give you x cubed. That's the basic logic behind that one. Then we're gonna have the middle term. The middle term, how do you find it? You multiply x by 1. You're gonna say x times 1. Couple this x times 1. X times 1 is x. Again. Then now the sign will be opposite. The sign that will sit here will be opposite from positive all the time. If it was negative here, it was going to be positive here. Now it's positive, that there is going to be negative. Which means it is always opposite signs when you are dealing with the root, the cube roots or the cubic. Now the last term, how do you find the last term? Is by saying which term can I multiply with this 1 to give me 1? Which term can I multiply with 1 to give me this 1? Is 1. You want to about 1 times 1 is 1. Now the signs is positive here. Come on, like positive times positive is positive. That's how you deal with it, guys. I hope we are all clear on that one. All divided by x squared minus x plus 1. Now, since we are multiplying here, you have a right to divide those terms that are the same. When you multiply, you can divide the numerator by the denominator of the terms that are the same. Therefore, this one is the same as this one. Excuse me. They're the same. Therefore, you drop down this one here, x plus 1. This is your answer, guys. I hope we are clear on that one. I hope we are clear. Now let's go to 2016. 1.1.1 November 1.1.1 November 2016. It's very simple now. You've got x squared minus x. Factorize. Now it's very simple. How to say factorize in this case? If you've got two terms and a minus in the middle. Now, if you've got positive or negative in the middle, look out for the highest common factor. Now, what's common between the first term and the second term? What's common is x. X is here and x is here again. you put it x outside the bracket. Okay. Now, the exponent here, you take out the one with the lowest exponent. Now, between x squared and x to the power 1, which one is low? Is x to the power 1. That means it's okay like this one. Now, to find the term here, our culture says that divide the first term with our highest common factor to find the term for this position. Now, what is x squared divided by x? Like when you divide same basis, you subtract exponent. Therefore, 2 minus 1 is 1. That's x. Why? Because x times x is x squared. That's the basic logic behind it. Then now, x divided by x is 1. X divided by x is 1. That means minus 1. Simple. Why? X times negative 1 is negative 1x couple negative x. That's the basic logic behind this question here, 1.1.1. Then we are done with 1.1.1. We are going to 1.1.2. 1.1.2. Now 1.1.2, it's simple now. It's 3x squared plus 3px minus 2mx minus 2mp. Now, this is factor by grouping. Factor by grouping. Now, how does it work? You must look out for the first two terms and the last two terms. Are they similar? Can I take out the highest common factor between the first two terms first and the last two terms? If they are similar, you group them basically. How do you group? We have got 3 here, x and x. Come on, 2 x That means I can see that if I can group these two first, and I can group these two, which is going to be our last terms, it's going to provide me the good answer here. Now, when I group them, I need to take out the highest common factor. Now, what's common between the first term and our second term? What's common? 3 and 3. 3 is here and here. I take out 3. I've got p on this side. I don't have p on that side. That means p is not common. I've got x and x. X is common. I take out x. Now, I take out when it comes to the exponents, the variables, I take out the one with the lowest exponent. Now, you've got x squared and x to the power 1. Which one is low? Is x to the power 1. That means I'm done with taking out the highest common factor. This is my highest common factor. How do I find the term for this place? Our culture says that the first term divided by our highest common factor. Now, 3x squared divided by 3x, x. Because 3 divided by 3 is 1. X squared divided by x. I give what's about 2. When you divide the same basis, you subtract exponents. Therefore, 2 minus 1 is 1. I hope we are clear on that. The second term, the very same process. 3px divided by 3x. 3 divided by 3 is plus 1. P in a variable. I put it. X divided by x is 1. That means there's no longer x here. I close the bracket, I'm done. The second bracket is very simple now. I've got negative 2 and negative 2 here. That means negative 2 is common on both sides. Therefore, I take the very same negative 2, I take it outside the bracket. I've got m and m. M is common on both sides, therefore, and it's m to the power 1. That means I'm taking out m to the power 1. Okay? I put m here. P, it's not common. I leave it like that. I open a bracket. This is my highest common factor for the second bracket. Okay? Now, our culture, it says that negative 2mx divided by our highest common factor. Negative 2 divided by negative 2 is positive 1. Okay? Positive 1. Okay? Negative 2 divided by negative 2, positive 1. M divided by m is 1. I'm left with x. I hope we are clear. Negative 2 divided by negative 2 is 1. Invisible 1. M divided by m is 1. There's no longer m. We are left with only x. I bring it down. The very same thing we do on our second term of this second bracket. Negative 2mp divided by negative 2m. Negative 2 divided by negative 2 is plus 1. I put plus here. M divided by m is 1. There's no longer m. M is no longer existing. P, I bring it down. Then I'm done with my brackets. Now, I must check if my brackets are similar or what. If they are similar, bring down only one bracket.
because they are common. In this case, yes, they are common. It's x plus p, x plus p. Therefore, they are common. I bring one bracket down. Then the remaining terms outside the brackets, I combine them. 3x minus 2m. 3x minus 2m. Then I'm done, guys. I hope we are clear on that. That's how you get your full marks for this type of questions. I hope we are clear. If you don't understand it, please reverse your video if you don't understand what is happening here. Let's go to another question. 1.3. We've got 2p squared minus 2p minus 12. Now, this one is quadratic trinomial. Quadratic tri means 3. We've got 3 terms here with a squared and a coefficient with a variable and our constant. Now, a quadratic trinomial, if we've got squared here, you open 2 brackets. First thing first, you open 2 brackets. But before you open 2 brackets, now for this quadratic trinomial, guys, first thing first, you need to at least make sure that your p squared does not have any number besides 1 in front of it. In front of p squared, we've got what? We've got 2. We need to make sure that we have got only positive invisible 1. Like I must make sure that we have nothing here. It's like this. You need to make sure that p squared, in front of it, there's nothing. It's only positive 1 that is invisible. Now, in this case, we've got 2. Okay? Can we remove this 2? Yes, I can remove this 2 because of what? I can divide each and every term by this 2 so that I can remove it. Because I can see that this 2, it's common on my middle term, and this 2 again is common on my last. That means 2 is common on every term of this expression. Therefore, I'm going to divide both sides, all the terms by 2. You divide all the terms by 2. This 2 divided by 2, keep p squared here. Negative 2 divided by negative 2 divided by 2, okay, minus 1 here. I bring down this p, it over p. Negative 12 divided by 2, okay, minus 6. Therefore, this is the proper question here. This is the proper quadratic trinomial. Therefore, if it's a quadratic trinomial, you know, I've got a squared and a coefficient with a variable and a constant. I open 2 brackets. Now, you know, what sits here is our factors of p squared. What are factors of p squared? Is p and p. Labo. Now, how do you find the terms? You need to find the factors of our last term, which is our constant, which is 6 in this case. What are factors of 6? 1, 2, 3, and 6. Are you agreeing with one another? Now, you need to find 2 terms from these factors. You need to find 2 terms of which, when I multiply them, they give me 6. And when I add them, they give me the middle term. In this case, it's negative 1, invisible. We need to have 2 terms. When I multiply them, they give me 6. When I add them, they give me negative 1 in the middle. How can I get 6 times 1? I give it 6 times 1 is 6 again, guys. But 6 plus 1 gives 7. And you can change the signs how by all means. You can say negative 6 plus 1 give negative 5 again. We can literally say you can remove the signs how. You must just play with it's trial and error, guys. 6 minus 1 is 5. About negative 1, remember, it means 6 and 1 don't qualify. You remove them. It's trial and error method here. Remember, 3 times 2. 3 times 2. 3 times 2 is 6 again. Correct. But remember, when we add them, they must give us the middle term. 3 plus 2 give 5. Does not qualify. We remove it here. We swap it, the deciding again. 3 minus 2 1. It means it's better, but we need to find we need to have -1, not 1, -1. How can I make sure that there is -1 here? Okay, I know that -3 plus 2, -3 plus 2 is -1. That means, okay, since well now 3 times 2 is 6, it qualifies, and -3 plus 2 is -1. It qualifies. That means this one, I take it of -3 plus 2. Now I'm going to have 3 and 2, and since well now 3 is negative, 2 and -3, and our 2 is positive, 2 plus 2 here. There are many ways to simplify it, but this is the one of the best ways to find the final answer for such questions. I hope we are all clear for this type of questions. Guys? Yes. I hope we are all clear. Let us go to 2015, November, paper 1, mathematics. 2015, November, paper 1, mathematics. Question number 1, factorize. We've got x to the power 4 minus 81. Now, this one is so good and proper. Now, finally, x to the power 4. We have got x to the power 4. It's an even number. This 4 is an even number. It's an even number. Now, in most cases, or in all cases, when you have got something like this, make sure that you break the first. I get x to the power 4. If you break it into exponents, when I have x to the power 2, close bracket, squared. That's how you break it. Always you must do this. Why? Because 2 times 2 is 4. It's a multiplication. When you multiply exponents, when the exponents, in this case, you must multiply exponents. You don't add them, you multiply them. 2 times 2 is 4. You only add them when we have got x squared multiplied by x squared. This is where you add them. But when they are exponents like this, you only multiply them. Now, it's about 2 times 2 is 4. That's how you do it. And this one again, you break it. And you want to say about 3 to the power 4 is the same as 81. Okay? Or we can literally say, okay, which term can it multiply itself to give us 84? We know what it is 3. I get 3 times 3 times 3 times 3. 3 times 3. 4 3s, they give us 81. 3 times 3 times 3 times 3, it gives us 81. That's how you break it. X squared minus, I give you're going to break it further into squared. I'm going to have 3 squared by squared here. This is how you do it all the time. You must make sure that it goes back to squared, not to power 4. You simplify it further, basically. Now, there's this rule here. A squared minus b squared is equals to a plus b, a minus b. This is the rule. I want to get another squared. You see, outside the bracket, we have got squared, 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 and our minus in the middle. Now, we need to write this in this form. Bracket by a plus b, close bracket, a minus b. Hurry more in that way. I have to buy 2 brackets. The first bracket, keep x squared plus. You remember minus. We've got plus. I have to buy x squared plus. X squared. And guys, plus 3 squared. Liable. Then another bracket bar x squared minus 3 squared. We are clear. I hope we are clear. Now, are we good? We are good. This is the rule. Please put this rule in your head so that when this type of question comes again, you use it. This is the rule, unfortunately. And let us make some changes. I give out about 3 squared is 9. 3 squared is 9. So you can write 9 here. It's the same as 9. 3 squared, it's 9. You can remove it. It's not a problem. It's 9. To make it things faster, ne? Okay, now x squared plus 9 cannot be simplified further. Therefore, you leave it like that. X squared, always x squared plus 9 cannot be simplified further because of what? 9 is not an even number. Only if we had an even number here, just like 2, 4, 6, 8, 10. 2, 4, 16, those ones. X squared plus 9 cannot be simplified further. You leave it like that. But x squared minus 9, it's a difference of 2 squares. Remember the difference of 2 squares. How do we simplify it? You open 2 brackets. What are factors of x squared? Is x and x. For 9, I get another squared. For difference of 2 squares, in most cases, if you have got squared here, I get another squared more. Therefore, find the square root of 9. Finally, 25 you're going to find the square root of 25 and you're going to write 5. Finally, 4, x squared minus 4, you're going to say the square root of 4, you're going to write 2 and 2 here. Finally, square roots are 81. I just want x squared minus 81. You're going to find the square root of 81. You get 9 and you're going to write 9 here. I hope you understand how does it work here. Now you've got the square root of, we've got x squared minus 9. Here another square demo, you're going to say the square root of 9. You get 3 and therefore you're going to say 3 and 3 here. The sign should be in opposite. Here another minus, you can write plus minus, vice versa. It's your choice. Therefore, you are done with this question. That's how you do it. I hope we are clear in this type of questions. Hope you are good, guys. Now 1.1.2 the last question here, 6x squared y minus 10xy plus 15x minus 25. This one is very, very good now. Now, it's factor by grouping. You first group the first 2 terms. You group them properly. You must make sure that they're similar. You can be able to figure the common factor. Okay. Now, it's trial and error method. Let us take out the common factor of the first 2 brackets. About the first 2 terms. You just check if it's gonna be possible. Okay? Now, how do you find factors in this case? How do you find factors? Okay? For this one, other factors of 6 and factors of 10. Okay? Factors of 6 is 1, 2, 3, and 6. Okay? Factors of 10 is 1, 2, 5, and 10. Now, from these factors of 6 and 10, which factor is common and is the highest? Basically, what is the HCF, highest common factor? 2. Okay? Therefore, 2, you write it outside the bracket. And for the variables, x is here. You take out x outside the bracket. In terms of the exponent, x to power 1, x to power 2. You take out the lowest exponent, which is x to power 1. For y is common on both sides. Therefore, it's y to power 1, y to power 1. It means it's y to power 1. You take it outside the brackets. You open a bracket. Our tradition is very simple. Our tradition, it says you go to the first term. It is 6x squared y divided by our highest common factor, which is 2xy. Okay? Then 6 divided by 2 divided by 3. Okay? Then x squared divided by x. Same basis, subtract exponent. Okay? When you divide, it's about 2 minus 1 x power 1. I get 2 minus 1 1. Okay? Then y divided by y 1. Therefore, I'm left with 3x. I write it here. 3x here more. 3x. And here, are we clear? Then the second one here, it says negative 10xy divided by my highest common factor, which is 2xy. Then negative 10 divided by 2, okay, negative 5. Okay? Then x divided by x, okay, 1. Y divided by y, okay, 1. Therefore, I'm left with negative 5 only. I'm going to write it here, minus 5. I hope we are clear on that one. Again, guys, we are clear. Okay? Now, the second bracket, I'm going to take out the highest common factor. Now, 15 and 25. What are factors of 15 and 25? 1, and here 3, 5, and here, guys, and 15. Clear? Are we clear here? Now, 25 again. 1. You've got 5. You've got 25. What is our highest common factor in this case? 5. Okay. Therefore, I take it outside our 5. Keep our plus 5 outside the bracket. And here, guys, are we clear? Are we clear? So, guys, we are clear. Okay? Then now, in terms of the exponents, the variables, x fella, that means 5 is alone outside the bracket because x is not common on both sides. You open the bracket, you say 15x divided by 5. 15 divided by 5, keep 3. Okay? Then x owner, you bring it down. Negative 25 divided by 5, keep minus 5. Then you are done, guys. Then you check again if our brackets are common now. Yes, because it's 3x minus 5, 3x minus 5. Therefore, you bring down one bracket bar, 3x minus 5. Okay? Then what's left outside, you bring it inside one bracket again, which is 2xy plus 5. Then you are done. Literally done, guys. Thank you very much. Until we meet in the next video. Sharp.